We're going to be starting our second unit, which is two-dimensional kinematics. And for this first part, as far as vectors go, we're going to skip a little bit of it. We would have done it if we were in class, and I could provide you guys protractors and rulers in order to draw out the vectors. But it's not that important. As long as you kind of understand the basis of it, it's not important that we practice that, because more often than not, you're going to be asked to find vectors mathematically than by actual measurement. Okay, so we're going to start with the directional system. So we're going to label the 8 main directions and the corresponding angles on the compass here. So let's start with our north. This is at 0 degrees. Okay, then we have east, and this is at 90 degrees from north. Okay, and then we have south. This is at 180 degrees. And then we have west, which is at 270 degrees. Okay, and then we have these things in the middle of each of them, intersecting them. Okay, so first we have northeast. And this is at a 45-degree angle. Okay, so here we have a 90-degree angle, and then so here would be 45 degrees from north, would be northeast. Okay, the next one is southeast. And it's at 135 degrees. We have the southwest. And it's at 225 degrees. And then we have northwest. And it is at 315. Okay, so those are the basic ones, and we're kind of going to go through like how we write down vectors with these different angles here in a little bit. Okay, so drawing vectors, like I said, we're not going to do this, but I'm just going to kind of go through the basics of this. So we're going to go ahead and start with our compass. So we have north, south, east, west. Okay, and then for our actual line, it's 25 centimeters north. So it would look like this. So 25 centimeters, or 2.5, sorry, 2.5 centimeters north. Okay, for the next one, okay, this one's going to be slightly shorter than A was, and we are going southeast. Okay, so we're going to come out at a 45-degree angle. Well, it's a 135-degree angle. Okay, so this would be our 1.9 centimeters southeast. Like I said, if we had rulers, we could actually measure out 1.9 centimeters and make sure that our vector is actually that long. Okay, for this last one, draw in our compass. It's going to be 1.5 centimeters. And now you'll see this is not a perfect southeast, southwest. We have north 20 degrees west. Okay, so what you want to do is identify the line in which, or the direction in which it starts with. So we have north here. Okay, so from our north grid line or compass line, we're going to go 20 degrees west. so this direction. Okay, so when we draw in our line, it'll be 1.5 centimeters, and this would be 20 degrees, okay? Because from the northern compass line, we went 20 degrees west, okay? So hopefully that makes sense. We're going to go through some practice problems that hopefully you'll kind of get the hang of the way that they write out these different problems. Okay, so this would be a huge section in which we would practice all of the different vectors by drawing them in. I'm just gonna kind of like skip through some of them just because we're not together, like I said, and you don't have protractors and things like that. So I'm gonna skip through all these basic ones. Those would just go on the basic compass. Okay, if we were doing E, okay, it would be 3.7 centimeters north, 20 degrees east. So if we had this is our E vector. This would be the 20 degrees, okay, because we had here, we're starting with from the northern boundary, we're going to go east 20 degrees, okay? For F, okay, we have 2.3 centimeters south, 15 degrees west, okay? So from the southern compass, we're going to be going west, okay, 15 degrees. And I don't have a compass on here, so it's just a guess. If I label it, that makes it a bit better. Okay, so this would be our F of 2.3 centimeters, south 15 degrees west. Okay, I'll do one more of these just in case. Let's go ahead and do this next one, G. Okay, so it says 3.2 centimeters east, 30 degrees south. So we're going to go find our line that we're basing it off, which is our eastern compass line, and we're going to go south, which is that direction, 30 degrees. Okay, so this would be 30 degrees. Like I said, it's probably not to scale. I don't have a compass, but 30 degrees, and this would be our G, which is 3.2 centimeters. Okay, so hopefully that makes sense. If not, reach out to me and I can help you as we go along with these different problems. Okay, so the starting point of a vector is sometimes called the tail. Okay, so that the tail would be this portion of the line. Okay, and then the end of the vector is called the arrowhead or head. So this portion. Okay, so to add the two vectors, A and B, you start by drawing the vector A, then draw B beginning from the head of A. Okay, so this point here should start at that point there. Okay, because at the end or at the head of the A, it should be where the tail of the B begins. So when you're done drawing both vectors, you will draw a resultant vector. Okay, so the resultant vector is here. So from point A to the end of point B, this would be the resulting vector. So it's going to be at the tail of A and at the head of B. So then we can measure the magnitude and direction of this resultant vector. Right, so if we had a protractor and a ruler, we could actually measure out this line. Okay, I'm not going to go through the practice here. but I'm going to go through some of these practice questions. Instead of assigning them as homework, I'm just going to go through them since we didn't actually kind of write out these different things. Okay, so you found B, D, and D plus B. How did the resultant vector compare? Does order matter when adding vectors? Okay, so if we had, let's say B was this, and this was D. Okay, if we have B plus D, it would be this with a result of this. Okay, if we had D plus B, it would be that, and our resultant would be this. Okay, so it doesn't matter when adding numbers. When adding vectors, it doesn't matter because it's cumulative. Okay, so these are both going in the same direction, so we would be adding them. Okay, compared to if they were going in opposite directions, we'd be subtracting them. Okay. So when adding vectors that are collinear along the same line that are north and south, is there a better way to find the resultant vector than drawing and measuring the resultant? Okay, so if we were using to scale drawings, and say I had a ruler and I measured out, and let's say I have a line, a vector that is 5 centimeters north, and then I have a line that is 2 centimeters south. Okay, I can measure this to find what the resultant vector would be. Okay, but an easier way, if you kind of remember back to whenever we were doing displacement, is we can subtract. Okay, so for example, vectors in same direction we're going to add, okay, vectors in opposite direction, we're going to subtract. Okay, so for example, if we have 5 meters north and 2 meters north, we would add those. And if we had 5 meters north and 2 meters south, we can change the 2 meters south to negative 2 meters north. And then whenever we add the vectors, it would be 5 minus 2. Okay. Vectors can also be multiplied by scalars to change the magnitude. So scalars are just quantities without direction. And sometimes even change the direction. If a scalar is positive, just multiply the two numbers and keep direction. If the scalar is negative, multiply the number and make the direction opposite. Okay, so for part A, if we have 4 centimeters south and we multiply the vector D by 3, we would have 4 times 3 is 12. It was positive, so we're going to keep the direction of south. For B, we have 2.3 centimeters south, 15 degrees west. Find 5.5 times E. So we're going to take 5.5 times 2.3, and we'll get 12.65 centimeters. And then because we didn't have a negative, we're going to keep the same direction. So south 15 degrees west. Okay, for part C, we have 3.2 centimeters, east 30 degrees south. Find -2 times F, vector F. Okay, so first let's do the numbers. So we have -2 times 3.2, and we'll get -6.4, but I'm going to go ahead and change the direction. So I'm going to have a positive 6.4 centimeters, okay? Because it was negative, I'm changing direction. So instead of east, it's going to be west, 30 degrees, and instead of south, we're going to have north. Okay, so both directions are opposite. All right, and then for the last one, we're going to take -1 times the vector of g. So 1 times 4.2, we're still going to get 4.2. Because it was negative, we're going to change the direction. So from west to east, 5 degrees from north to south.